Thank you for being here, everyone. I'm Emanuele Morra. I'm from MFB Consulting. We are a consulting company, and I'm professor at the Polytechnic of Turin for supply chain and industrial plan. And today I'm very glad to be here because I would like to guide you through a real case study where we applied a customized cross-dock sourcing policy within a European aftermarket spare parts network. Leveraging anyLogistix simulation capabilities for a real case study we had this year since January. This project was based on the real case study for this sourcing policy, but it has a very big context because this is, as you know, within the automotive market, which is going through a very difficult period in these years. From our side, we are a consulting company that usually follow all the project with the initial condition, with the modeling support, we do training, and we are partner of Logic Europe for anyLogic and anyLogistix tools. This is my partners in MFB. We are based in Switzerland, in Olten, and we have international project, I would say. Let's go through the agenda. Today, I will guide you through the case study, the scope of work, and how we manage and handle these specific cases. So how we had chosen to develop the scenarios and the model, and of course, how we tested and verified our results for our client. I anticipated we have got a good result and amazing achievement with this project, with good reaction and opinions and feedback from our client that is now using anyLogistix as a real user, I would say. So we plan also some next steps to improve our model. Just to give a little bit of context, you know that the spare parts market is divided into two main challengers. One is OEM, the original equipment manufacturer that produce spare parts for their vehicles. Of course, they do consistent quality parts and warranty support. So, of course, they are the majors about this topic. But the challenge with the aftermarket part is really increasing with production that is increasing in the last years, have been increasing a lot. You know that the price is lower than 50% usually respect to OEM equivalent spare parts. So we think that supply chain digitalization could play a very important role, I would say critical, in improving the supply chain, which is very important because they need real-time visibility. They are aiming to introduce AI, machine learning for planning, and of course, a simulation-based decision is always fine for them, and that's the case I'm going to show you today. You know, automotive aftermarket key trend is increasing, so the OEM, the manufacturer, need to be more efficient, need to be challenging this market because, you know, also e-commerce is in expansion. There are a lot of emerging trends like the electric vehicles parts, customization, sustainable components, and so sometimes OEM need to do supplier alliances to have a specific supplier within some national market. And of course, even within a regional market, the supply chain is playing a very important role. And the help of tool like anyLogistix is very welcome to them. Car manufacturers on OEM spare parts are, you know, challenging a lot of specific features. They have high customer expectation, especially for the next day delivery. When we are dealing with automotive supply chain, we usually manage thousands of SKUs and part numbers. Also, the service level agreements with the dealers and workshop is very challenging, and the distribution across multiple countries is very hard. Of course, the KPI of lead time is something very critical for them, and so cost pressure and inventory balancing become not so easy in that case. OEM are facing the aftermarket, the third parties, even if we really don't know exactly from their information, from the market, from the operating margin, and so on, which is the real impact of this, I would say, sector. But we know that spare parts are really important because this is critical for maintenance and servicing of the car. Supply chain digitalization also can play an important role, of course, but there are priorities. In fact, in our case study, we were focusing to build a model that can mirror current operation, to explore future scenarios, especially through what-if simulation, which is very important because the structure of big manufacturer is very highly detailed. There's a lot of tiers. So what if scenario, if you want to move a group of SKU or to manage different inventory policy or strategies is really important. And this chance into the tool is really manageable because you can do comparison experiment, and that's what we have done in this case. But the real scope, which is important and also give a very important achievement, is to drive a smarter and faster decision making with simulation. So to help the top management in taking decision on doing analysis that can lead them now to investment or big changes in the strategy, in the structure. The main KPIs we were focusing on during this consultancy were the lead time for delivery, which is, I think, the most important KPI for supply chain and spare parts. And then, of course, the effect on the logistic cost and the rest of the cost, also the management, sorry, of the plant, the cost for labor, the cost for storing goods day by day. So really detailed analysis with a lot of parameters and very huge model. The structure, the architecture of this case study was based on a central distribution center with a star schema logistics connection to national warehouses. We have been analyzing all, I would say, the West and Central Europe market, 5 national distribution centers that were feeding the dealers through an intermediate distribution center tier architecture of usually more than one layer. These policies were based on truck logistics and with 2 different policies. One for the planned stock transfer, so to provide goods at the warehouse with a predictive tool, which is not any logistics, I would say. And then the cross-dock policy when the national market has no item, so when there is some SKU that are not available on the shelf, so you can do instant allocation. The lead time benchmark is 1 day, so it's very challenging in that sense. We try to build a real digital twin, so a full model with all the information within. So the demand were real demand, a monthly scenario covering up to 60,000 of different orders with daytime, so historic demand. SKU with a catalog, portfolio product of more than 16,000 of items. And this is very challenging, you know, for anyLogistix to manage within one scenario all of this information. Also the customers that for us were the end of the supply chain, so the dealers to market with more than 4,000 spare parts dealer widespread over Europe. Also, the economic costs have been put into the model with high detail, transportation cost for interrupt shipments, processing cost, the central distribution facilities, inventory holding cost. And also for the time, we put inside a very big scenario, 1 month of real EU demand at the dealer level, Linehaul transit time, fixed duration, including handling at main logistics centers, last mile delivery with an estimated delivery times to local outlet based on vehicle speeds, cross-docking, so processing time required at the national distribution hubs, and remote location, so additional delays when you mean to reach island that requires additional time for to be reached over the sea. Also, the operating hours. This is something that is really important when you work with lead time and real dealer, because these are shops at the end of the day, and daily working schedule applied to warehouses and retail point, for example, excluding weekends. This fact has a real effect on the lead time statistics, and we manage this with good success. Our process flow was quite ordinary. We defined the project objective with our client. We have been through data collection, very highly detailed, with the master data from their databases. Then we build the model and validate the model with the departments and define more than one scenario. And of course, every time we had a simulation, we discuss with the digital team of our customer to see if the result were, I would say, coherent with real situation. So sometimes we keep the model, sometimes we skip the model. And at the end of the day, we create the report. When I say report, I don't say only statistics for the technical team to work on the scenarios, but especially report for top management, for steering committees to analyze critical situations about mainly inventory and lead time topics. We managed through a very detailed plan that has been working through the first 4 months of 2025. We go through the database to get the data for transportation, for cost, and also we extract data from the main comparison we have done from the stock transfer and the cross-dock that is done to reach emergency, for example, when the SKU are not available for instant allocation within the national market. Then we define the rules and the concept and design. This is very important because when we get there, we found the need of doing a sourcing policy that were custom, because the algorithm was dynamic and the way that every national market has been replenished by the central one is very remarkable and peculiar for this client. Then we had all the simulation and the scenario preparation for every national market, and then testing and simulation on the overall system, putting everything all together in a very big full model. The extension was the core of this job. We worked along with the support, the technical support from anyLogistix. We were bothering Roman many times on this policy, because we need something with a multi-level fallback, where every hub can reach the regional distribution center and then back to the distribution center, which was the central one in Germany. This is very big warehouse, but if the SKU is not available, even at this point, the algorithm fall back again through all the other regional distribution centers that can help into the emergency situation. This was very important for us. So we forced the routing through the central DC. This is a peculiar thing, but this can be helpful in a specific geographic configuration. And the dynamic selection algorithm. At the core, what we implemented was dynamic algorithm that selected the most appropriate path based on delivery time and inventory status, not just static sourcing rules. So this means that the model reacts to each request in real time, adapting sourcing decision depending on the system condition. Also stock out configuration. Depending on the scenario, the simulation could either stop, record the lost sale, or skip the other. This flexibility allowed us to simulate both best case and worst case environment. This is crucial when you are stressing the network. And then full interoperability. Thanks to the support by anyLogistix and the cooperation with the team from our client, we have been able to extend this sourcing policy and embed it into the anyLogic-based model, very robust, and we tested and stressed the policy with a lot of data, a lot of scenario, and at the end, through, I would say, 3 releases in a couple of months, we reached a very good result. And we have been able to mirror what the client could only previously manage through manual coordination, spreadsheet, reactive decision, and so on. So now the model is able to allocate order across the network automatically and delivery impact and cost deltas in real time. So very important for what if scenario. Extension is the core, but the model was very huge. We had a lot of data inside, and you know, when you have a lot of path, a lot of connection, a lot of policy. For example, the inventory rows were more than 100,000, so very big model. Sometimes also hard for the support of anyLogistix to handle, but at the end we succeed, and the model gave the good result. Here you have some screenshot of the user interface from anyLogistix, and we had one full model for the Linehaul over Europe primary logistics and the final mile, the last leg to the dealer with real simulation. What we tested and verified was, I would say, full simulation on every national market. We get through a lead time heat map that was very important for our client to show to the top management the result with only one image, one picture. You know, it's simplifying, but it's important. And then we were able to integrate every specific parameters that the client asked us to put into the model as a data entry. So including also KPIs, statistics, service level, the replenishment frequencies, the sourcing policy. The big goal we achieved was this functional validation from the client of this extension for the sourcing policy for reallocation at European level in case of local item unavailability. And of course, in the what-if scenario that we have been able to modelize and to run, also the parameter of instant allocation at the national warehouse level has found a very good result. Big likelihood with a real case study and some design for safety stock profile and using the standard feature of anyLogistix that allow us to have a model with a stock profile, with a safety stock profile to reach instant allocation around 98%. And we verified this, and it was very well appreciated by our client. Also, the chance to use a group and subgroup of SKU, very important, to get at the end the comparative what-if scenario analysis of an alternative storage policies for low turnover items. This was one of the goals, and focusing this on the lead time and total cost. Here is some result in achievement. So different scenario can get through lead time increasing or lead time decreasing, and managing in the same time best inventory location, also reducing or increasing local cost. You know that placing the distribution center in the right country is not so easy now with different cost, but different impact on the lead time. So sometimes it's better to have a lead time of 1 day, even if you are losing some money to manage the warehousing. Takeaways is successful case study, so everybody happy, us, the client, and anyLogistix. Good for automotive. It is important achievement because in the past, anyLogistix weren't able to reach the operational level of working. Now we have. It's not only strategical or tactical. Of course, the need of integration with the BI tool, very important for visualization and showing to the top management that well received our strategic relevance in the job we did. We have been able also to isolating subsystem, really important in a complex supply chain, and then the customized cross-dock policy is perfectly aligning with the operational goal. Next step is automation with the data sources, refine and scale the extension framework, of course, with the integration with BI, and then perform extensive multi-period validation, so to test and stress with more than 1 month of demand. Thank you very much for your attention. I hope I have been in my time, and really happy to see some Q&A if you have, and thank you all for being here today.
Shannon, for joining us today, and yes, we do have time and we do have questions to you in the Q&A box, so I suggest we look there and give some answers to our viewers. So I can read them for you. Sergio is asking, how did you define and calculate the different lead times and shipping costs?
Okay. Well, lead time it was a result for the simulation. So we use the standard feature of statistics, and it was our main goal to analyze lead time, customer dealer by dealer, country by country, and also comparing the lead time as I would say an average one for every subgroup. Also, we divide every country in different sub areas. For example, in Italy, you know, there are Italy is long, so for example, on the island and on the bottom of the boat, there is a very big issue in lead time. So this was very, very important, and this was the main goal. But we use standard feature from anyLogistix.
Thank you. I hope that answered Sergio's question. Another question that came and that I see is the following: how long do the simulations take time, and what statistics setup did you choose?
Yeah, the time for simulation was at the end with a full model with 60,000 of dealers, very long for to being quick, of course, and testing more scenario. With this such a data entry, we had simulation within sometimes 20 minutes for the run and 5 to 10 minutes for achieving the statistics. Statistics dashboard was set up to the highest level. So we have the scheduling. You know that with these statistics, the system requires a lot of time for doing the calculation, but we had every track for every item, for every action, so loading, unloading, descending. So we have the full track for all the shipment, and this is really highly demanding in terms of memory and power of calculation.
Yeah. Speaking about the entry, there is also a question about it. How tricky was the data entry itself?
Well, as always, the data preparation is always tricky, so I cannot say different, but this time, despite of many other projects that we have been through, our data team was really working with us and is not so usual. And they give us a lot of data sets, predefined, preset, pre-cleaned. And so it was not so tricky because of the help. So this time was a little bit different. So my understanding also for the team that use anyLogistix is that the trend is to put data team into this project, and this speed up a lot the creation of the model and the testing and verification. So this time not so tricky, help thanks to the help we received by the team.
Great to hear. And the final question that I also see here is about digital twin technology itself. So a question to you, Manuel, how powerful, how important do you find and how useful it is in logistics? I think you covered it up, but still, what are your thoughts on this?
Yeah, you mean about the power of calculation?
Yeah, I guess so.
Well, we use a laptop at the end, powerful laptop with 64 gigabyte of RAM. I don't know if this is a question, but we don't use a server. So in this case, we only go with laptop, which you know is powerful and it's very flexible because you can move scenario from one user to another very quickly, even if we had a chance to use the server license. But I think we are reaching the limit of our laptop in terms of memory and speed of calculation. But at the end, even if it was a little bit hard to wait for every simulation, but we reached the goal only with laptop that you can find on the market. So 64 gigabyte of RAM, so you can find it on the market.